All right, so problem 4 indicates whether the statement is always true or sometimes false. Justify your answer with a logical statement or counterexample. Okay, part A. If A is a square matrix with two identical rows, then A times A has two identical rows. Right? So let's say A is a square matrix. Right? It has two identical rows. For example, this row and this row. I don't know which two rows. I just call them the ith row and the jth row. Okay, then A times A. What is A times A? A times A. Okay, here we need to use one very important statement. So A times A's ith row, okay, is what? Is A's ith row times A. Okay? So here, if you're not familiar with this, you can, later when I upload the video, you can go to question 3 to see the details. Okay, I showed a little bit more there. But here, A times A's ith row is equal to A's ith row times A. And we already know A's ith row is equal to A's jth row. Right? A's ith row is already equal to A's jth row. And A's jth row times A is A times A's jth row. Right? So that's why if A has two identical rows, A times A must also have two identical rows. Okay. All right. Part B. If A is a square matrix, right? So if A is a square matrix and A times A has a column of zeros, then A must have a column of zeros. Okay, then A must have a column of zeros. All right, is that true? Okay, is that true? And so it's not like numbers. When two numbers, the product is 0, then at least one of them is 0, right? But here is a matrix multiplication, right? What if the result have a column of zeros, right? Must there be a column of 0 in A? Okay. So here, it depends on how do we get 0, right? 0, because for the matrix multiplication, right, the result entry is the first entry times first entry plus first entry times second entry, right? So the idea is 0 could be 1 times 1, right, plus 1 times negative 1. Okay, that's the idea. So let's just say, let's keep it simple. Let's just use a 2 by 2 matrix. So 1 times 1 plus 1 times negative 1. So let's say if this matrix looks like this, right, then it multiplies itself. Then the result is also a 2 by 2 matrix. Here, 1, 1, right? Here, for example, 1, 1 times 1, negative 1, right? The second entry is 0. Okay, 1, 1 times 1. Here, if this is also negative 1, let's see what will happen. Okay, if this is also negative 1, 1, 1 times 1, negative 1, result is also 0. Here, negative 1 times 1, negative 1, result is 0 as well. Here, negative 1 times 1, negative 1, right? The result is 0. Okay, so this is a very clear example that it doesn't have to contain any 0, but the matrix multiplication could be all 0. right? So it's a counterexample. Let me give you the first question finally, right? From the proof, we know part A is true. Right? Part B, because we find a counterexample, right? This is a counterexample, so part B, the statement is false. Right? Part C. If the matrix sum AB plus BA is defined, then AB must be square. Okay, then AB must be square. So let's see when AB plus BA is defined. Right? AB plus BA is defined. Okay, so let's say A is M by N matrix. Okay, it has M rows, N columns. B is let's say it's a P by Q matrix. It has P rows, Q columns. Right? So here AB plus BA is defined. Three things. First thing, AB is defined. Okay, BA is also defined, and this plus is also defined. Okay, so let's see. AB is defined means what? Okay, because A is M times N, B is P times Q. So AB is defined. That means N is equal to P. Right? AB is defined. That means N is equal to P. BA is defined. Okay, BA is defined. Same thing. B is P times Q. Right? P by Q matrix. A is an M by M matrix. Then B times A is defined. That means Q is equal to M. Right? The number of columns of the first matrix must be the same as the number of rows of the second matrix. So here, Q is equal to M. Right? Then AB plus BA is defined. Okay? Please turn off your phone. AB is what? AB, after the matrix multiplication, it is M by Q matrix, right? And BA, after the matrix multiplication, it is a P by N matrix. Okay, it is a P by N matrix. Then two matrix, you can only, right, do the addition of two matrices of the same size, right? Only when they are of the same size, then you can plus them. So, all right, the addition is defined. That means M is equal to P and Q is equal to N. All right. So, as you can see from these four equations, actually M and PQ, they are all the same. Right? From these four equations, you can see M and PQ, they must be all the same. Right? So here you can make a conclusion. Anyways, so M and PQ. Right? These four numbers must be the same. So A and B, they are both square matrix, which is true. Right? So this statement is true. Okay, this statement is true.